Are you a numbers person? Or are you a words person? Well, today I want to show you that this is a false binary and that there are deep and beautiful connections between mathematics and literature. We tend to put mathematics in the science box and speak of it as being the language of the universe, and that's absolutely true, it is. The reason is that the universe is full of pattern and structure and symmetry, and mathematics is the best language we know to describe and understand and explore these beautiful things. That's why it's essential for science. But we human beings are part of the universe. We are part of that structure. Of course, our souls will delight in it. It's only natural that our forms of creative expression will include pattern and structure because we find not just joy, but meaning in those things. In literature, pattern is most prominent in poetry because every form of poetry has some kind of structure. And you know, we're almost born loving its rhythms. The first sound we hear, after all, is the iambic pentameter of our mother's heartbeat. But every poetic form has structure. The haiku, for instance, has a precise numerical constraint, exactly 17 sounds or syllables to get from setup to payoff. Meanwhile, the sonnet has 14 lines and a defined rhyme scheme that tells us which lines must rhyme with each other. So the first and the third, the second and the fourth, and so on. Now, these constraints do not hamper our creativity. They inspire it. It's the same in mathematics. Within the rules of Euclidean geometry, we can prove Pythagoras' theorem. And within the rules of a sonnet, we, or at least Shakespeare, can write, "Shall I compare thee to a summer's day? Thou art more lovely and more temperate." And just as in mathematics, when we understand a structure, we can exploit it to create something new. Shakespeare wrote a lot of sonnets, but it's nothing compared to French writer Raymond Queneau, who produced a little book whose title translates as 100 trillion poems. Now, how do you get 100 trillion poems in a book? The answer is by exploiting the mathematical possibilities of pattern. What Queneau did was to produce this book which appears to contain just 10 sonnets, each 14 lines, each with the sonnet rhyme scheme. But then he does something more. He makes all of the first lines rhyme with each other, and all of the second lines rhyme with each other, and so on. What this means is that we can create new poems by taking any of the first lines and following it with any of the second lines, and so on. In effect, it's a three-dimensional rhyme scheme. And it gives us 10 possibilities for the first line, times 10 for the second line, times 10, times 10, times 10, and so on, until we get 10 to the power 14 potential poems. And that's 100 trillion. So I love this idea because it raises some fascinating questions. Did Raymond Queneau really write 100 trillion poems? Can you be said to have written a poem that you haven't even read? And I know he didn't read them all because I did a quick calculation, and that would take over 190 million years. So he didn't do that. And now, if I make one of these poems by choosing the lines at each stage, have I written it? Well, surely not. Raymond Queneau wrote every single word of every single line. So who's written this poem? And if I get a machine to make the choices, what happens then? This is a wonderful lens through which to view these very current questions around creativity and authorship. But poetry is not the only place where we find structure in literature. In fact, it's everywhere. And we see this because really literature is geometrical. In geometry, you have a hierarchy of points making up lines, making up planes, and so on up the dimensions. It's the same in literature. Letters make up words, words make sentences, sentences make paragraphs, paragraphs make chapters, chapters make volumes. At every level, the author can make a choice. It's not which structure, it's not whether to use structure, it's which structure you're going to use. And the best works of literature involve the authors making that decision based on the effect it will have on their piece of literature. So, for example, the author B.S. Johnson wrote a book called The Unfortunates. where he wanted, as one of his goals, was to reflect the random way in which past and present interact in our minds, with the events we're experiencing right now bumping up against memories that come unbidden into our thoughts in a seemingly random, non-chronological way. So the book itself has a first chapter and a last chapter, but the intervening 25 chapters come separately bound in a box, and you can read them in any order. And if you thought 100 trillion was a big number, the number of ways of reading this book is this. Quite about 15.5 septillion. The exact number is there, if you want to impress people at parties with it, that's for you. But, this is such a huge number. If humanity were to, all of us now, start reading one version of this book every day, it would take us collectively over 5 trillion years to read the full set. So we're never going to be able to do it. And it's a brilliant way to experience that randomness. As Johnson said, this is an enactment of randomness that the bound book simply cannot achieve. And it's a wonderful way to show that no two people can experience even the same set of events in the same way. But I don't want you to think that these ideas are just the preserve of the, literary avant-garde. Of course, yes, there are people who have written books in which the length of each word is determined by the decimal expansion of pi. And that's great, they are living their best life. But for me, the use of structure is at its most compelling when it adds, as in B.S. Johnson's book, it adds to the theme of the work. So I wanted to give you an example of this in a fabulous and really well-known book, and that is The Luminaries by Eleanor Catton. It won the Booker Prize in 2013. It's got everything, this book, in the plot. It's got love, a murder, betrayal, opium, and a mystery of some stolen gold. And one of the themes of the work is the tension between chance, fate, free will, and destiny. And she illustrates this theme by incorporating astrological symbolism throughout. So there are 12 key characters, each loosely associated to one of the signs of the zodiac. And there are the luminaries of the title. Those are the lovers, that they represent the sun and the moon. And mirroring these ideas, there's a mathematical pattern at the heart of the book's structure. The book is divided into 12 chapters or sections, and to reflect the waning of the moon, each chapter is half the length of the one before. And that has a powerful effect on how we experience the book. I can show you visually. Here's chapter 1. Chapter 2 is half of that length. Chapter 3, half again. Chapter 4. Chapters 5, 6, 7, and 8 slotting in there. Chapters 9, 10, 11, and 12. We're making this beautiful spiral effect. And when you're reading the book, you feel it. You feel the tension building up. The gear wheels are turning. And we're closing in and in and in. On the very final chapter, it's just a short conversation between the two lovers. And it's set chronologically in about the middle of the action. So what we know, but the lovers don't, is that by that point, their fate is already sealed. They are trapped in that spiral. We can do some mathematical analysis of this kind of structure and work things out like, for instance, the whole length of the book based on just knowing the length of the last chapter. The formula tells us that to get the whole book length, you multiply that last chapter length by 2 to the power 12 minus 1. Now, I'm telling you this because you might think, Sarah, you love maths, that's great, but you're just sort of coming along afterwards and imposing this. Eleanor Catton isn't thinking about any of this stuff. Right? But I think I can prove that she absolutely is. That formula I just said, 2 to the 12 minus 1, shows us that 2 to the power 12 is vital to the structure of the book, right? It's fundamental. Now, remember I said in the plot there's some stolen gold. There's a court case around the gold, and its precise monetary value is stated. And that value is 4,096. And if you're mathematically minded, you might recognize 4,096. It's 2 to the power 12. So she gives us that little present in the book. It shows us, here she is saying, I know 2 to the 12 is vital to the structure. And stolen gold, it's sewn into the very fabric of the book. It's great. It's a brilliant way to use structure to enhance the ideas that you're writing about. It works well. So if you want to win all the literary prizes, Put mathematics in your book, that's my tip. But look, when you've got your structure decided, you still need to write the darn book. You still need to write the story. Here's another way that mathematics is involved, in the very language that's used. Numbers themselves form a fundamental part of the human psyche. And some numbers crop up over and over again in stories. Think of the fairy tales and folk tales of your own childhood. You'll meet 3 bears, 7 dwarves, 12 dancing princesses, and 40 thieves. These numbers appear over and over again. They seem to have immense symbolic resonance. The number 3 is particularly important for narrative, especially in fairy tales. It's not just 3 little pigs. It's 3 billy goats gruff. Let me think. You've got 3 wishes that the genie gives you. You have 3 good fairies. You have 3 little pigs. And more broadly, let's not forget the 3 fates and the 3 graces of Greek legend, or Macbeth's 3 witches. 3 really is a magic number. And there's a mathematical reason why it's so ubiquitous in narrative. Take a typical fairy tale structure. 3 brothers going on a quest. Now, the oldest brother, he thinks he's pretty great. He goes off on this quest, and he fails. That's a single data point, a point in space. Now, the second brother, who also thinks he's great, he goes off, and he fails. And now, geometrically, what have we got? 2 points. 2 points define a line. When you've got a line, you've got a direction of travel, you've got an expectation, and now when that third, youngest, humblest, overlooked brother goes out on the adventure and succeeds, we're surprised. We've gone away from that boring one-dimensional line. We've literally added a whole new dimension of interest to the story. That's why 3 is so vital for narrative, because it's the smallest number of times you can repeat something in order first to set up an expectation and then to subvert it. But 3 is not the only number in mathematics. One of the most famous quantities in all of mathematics appears in Jan Martel's book, Life of Pi, right? It's not just the name of Pi Patel, the boy who is stranded at sea for 227 days with a large and rather grumpy Bengal tiger named Richard Parker. The number pi itself is mentioned regularly in the text, and there are allusions not just to it being a number, but to its mathematical properties. As Pi Patel says, he takes refuge in this elusive, irrational number with which scientists try to understand the universe. Now, in mathematics, an irrational number is one that cannot be written as a ratio or fraction of whole numbers. Its decimal form goes on forever. But Pi's experience, the boy at sea, has this kind of dreamlike quality. We're never quite sure whether we can believe what he's saying. So in a clever play on words, the book asks about the boy, rather than the number, is Pi irrational? And you can decide for yourself if you read it whether you think he is or not. But there's something more. The fact that Pi, the number, can't be written cleanly as a fraction means its decimal goes on forever. We can never know it completely. And this frustrates Pi Patel. He doesn't like what he calls a bodged farewell. He wishes his story could have a clean ending. But there's a little treat hidden away in the duration of his time at sea. And in an interview once, Jan Martel said that he'd chosen the length of time, 227 days, before he'd even fixed on the choice of a tiger as the animal who is with Pi, that iconic feature of the book. So why 227? Well, it can't be a coincidence that 22 over 7 is a very, very good approximation to pi. So it's a beautiful bit of sleight of hand. Jan Martel is giving us an almost rational pi to end the story. It's wonderful. Now, lots and lots of classic authors have used sophisticated mathematical ideas in their work. Tolstoy talks about calculus in War and Peace. Dostoevsky talks about non-Euclidean geometry. George Eliot's novels are full of comments about statistics and probability. No one sat Herman Melville down and forced him at gunpoint to write about mathematical ideas in Moby Dick, but he did. It's full of mathematical ideas. He does it because he likes mathematics, and it just comes out in his writing. And if we're surprised by that, it's because we've forgotten what was natural for most of human history, really, that mathematics is just part of a cultural education. 1,000 years ago, scholars like Omar Khayyam were poets as well as mathematicians. Centuries before that, the Kama Sutra recommends that young ladies, as well as learning, let's say, other arts, also become adept at arithmetical recreations. And much more recently, there's of course the President of the United States who found a new proof of Pythagoras' theorem in his spare time when he was doing geometry for fun. Now, I know what you're thinking. It's not the current president. It's this guy, James A. Garfield. But look, if we're afraid of mathematics, we miss out on the chance to experience the transcendent beauty of mathematical ideas. For George Eliot, they were a real solace at times of stress. This is her recipe for relaxation. Here it is. I take walks, play on the piano, read Voltaire, talk to my friends, and just take a dose of mathematics every day. I just feel relaxed thinking about it. Wonderful. The same pleasure we get from reading a wonderful poem or novel can also be found in exploring an elegant piece of mathematics. Literature and mathematics, both, are part of humanity's search for beauty and meaning and truth. And by uncovering the deep connections between them, we can enhance our enjoyment of both. Thank you.